Hello, good evening, Aditi. How are
Good
you?
evening, sir.
How are you?
I'm fine, sir.
Okay, good. Okay, welcome to
I'm
YouTube.
fine, sir.
Yeah, yes, Aditi. Okay, welcome to YouTuber
Hello.
World, Aditi. So today I'm going to explain you a few questions in chemistry. So we are going to see how we can easily solve those questions or how quickly we can solve those questions. Okay, so let's start with the question number 1. So Aditi, for a numerical question, always remember, first go through the question carefully, focus on what is given and what needs to be determined. So these two things you are going to focus, what is given and what needs to be determined. So I will read the question. An unknown gas was collected over a water. Determine the molar mass of an unknown gas if 0.167 gram sample occupies a volume of 69.8 ml at 60 degrees Celsius. The barometric pressure is 752.8 torr. Now, Aditi, here the molar mass is asked, and what is the given data? The mass of the unknown gas, volume of the unknown gas, the temperature, and remember the barometric pressure is given. The pressure of the unknown gas is not given. What is given? The barometric pressure. And please note this barometric pressure, I'm going to write down here so that it will be more clear. This barometric pressure is nothing but pressure of unknown gas plus water vapor pressure at a 60 degrees Celsius. Okay, because the temperature given is the 60 degrees Celsius. Understood this, Aditi?
Yes, sir.
Okay. Now, once you get to know the data, like what is given and what is asked, the next thing is the how you are going to solve the question. So let me focus on the solution now. So the step 1, let's see step by step. Step 1 will be you are going to determine the pressure of the unknown gas. Pressure of unknown gas. How will you determine? The barometric pressure, that is P total minus water vapor pressure at 60 degrees Celsius. Aditi, this you will get from the data sheet. Okay.
Oh, sir.
Okay. So this value will be given to you. And what is the step number 2? Once you got the pressure of the unknown gas, step number 2 will be use relation between pressure, volume, and the temperature. So what is that relation, Aditi? We have a PV is equal to nRT. P is the pressure, V is the volume, N is the number of moles, R is the gas constant, T is the temperature. Or we can write this equation as a PV is equal to M by M RT, where M is the mass and capital M is the molar mass. Just a minute, Aditi. Okay, Aditi, understood this? So M, small m is the mass of the unknown gas, whereas the capital M is the molar mass of the gas. You are getting this point? So what we are going to determine here? We have to determine the capital M, that is the molar mass of the unknown gas. Right, Aditi? So the step 1, get the value of the unknown gas pressure. Step 2, use this relation PV is equal to small m by capital M multiplied by RT. Now we are going to put the values and we will calculate the molar mass of the unknown gas. You are clear, Aditi, regarding these two steps?
Yes, sir.
Okay. Okay. Now let's put the values. So Aditi, as I mentioned, step 1. So pressure of the unknown gas. How much is the total pressure? 752.8. 752.8 torr. And Aditi, units are very important. Always focus on the unit. And as I mentioned from the data sheet, the vapor pressure of water is 149.4 torr. So calculate this and tell me the answer, Aditi.
603.4 torr.
Very good. 603.4 torr. Absolutely correct. Very good. Now the next thing is the putting the values in the PV is equal to M by M RT relation, or we are interested in the molar mass, capital M. Molar mass. So this will be equal to small m R multiplied by T divided by PV. Right, Aditi?
Yes, sir.
Okay, very good. Now let's put the values and get the result. Okay. So just a minute. R value will be given to you. So I'm just keeping it this value here so that you can use it for your reference. Yes. So Aditi, one by one, tell me the values. What is the mass of the unknown gas? 0.167 gram. Right, Aditi? Multiplied by. Yes. So value of R you are going to use in the torr. This is the value we are going to use. So how much it is? 62.36 liter torr mole inverse Kelvin inverse. Now the temperature. Aditi, temperature is given in the degree Celsius. So we need to use it in the Kelvin because in the unit of R, it is in the Kelvin. So if you convert degree Celsius to Kelvin, how much it will come?
333.
Very good. Correct answer. 333 Kelvin. So I'm going to put it here. 333 Kelvin. Okay. Good. Very good. Whole divided by. Now pressure we have. So how much pressure we have calculated? 603. 603.4 torr multiplied by volume. Now volume should be in the liter. So I will write down this as a 69.8 10 raised to minus 3 liter. Okay. So Aditi, we will calculate this and then we will see what is our final answer. So you are going to take some time to solve this. Just try, I will help you. Don't worry, even if it's wrong, I will tell you the correct answer. Okay.
Sir, 82.4 gram per mole.
Yes, absolutely correct. Very good. It should be 82.4 gram per mole. And you have mentioned the unit also correctly. The molar mass unit should be gram per mole. And the answer is 82.4. Very good. Good. So this is how we have solved this question. Understood?
Yes.
Very good. Now, one more question we are going to solve. And as I mentioned, your answer is correct. 82.4. Good. Now the next question. So Aditi, whenever question will be asked, so what will be your how you are going to proceed? First, read the question carefully. What is given? What needs to be determined? And then spend some time on your strategy, like how you are going to proceed. So can you read this question?
Yes, sir. An unknown gas is determined to have an empirical formula of CH2 if a 0.176 gram sample of this gas occupies a volume of 35 milliliter at 134 kilopascal and 175 degrees Celsius. Determine its molecular
Molecular
formula.
formula. Very good. Okay. Now, what is asked? So molecular formula is asked. What is given? Highlight the given data. Empirical formula is given first. Then the unknown gas mass is given. Then the volume of the gas is given. Also the pressure is also given, but it's in the kilopascal, and the temperature is given. Right? This is the given data. Molecular formula we need to determine. How we are going to proceed? The first thing, Aditi, you will do here, that is the step 1. Get molecular or molar mass of unknown gas. That is the first step you are going to do. How you are going to get the molecular mass? So just now we have seen. So molecular mass M is equal to wait a minute. Molecular mass M is equal to M R T divided by PV. So you are going to use the pressure, volume, temperature relation. What will be the step 2? Step 2 will be the getting the multiplying factor. You know, like there is a relation between molecular formula is equal to multiplying factor, that is N multiplied by empirical formula, which is given. What is that? That is CH2. So let me write down here. That is given. I will write with another color. It's a CH2. But now you might be asking, sir, how to get this N? How we are going to get the value of N? So it's very easy. So N is nothing but molar mass by empirical formula mass. Empirical formula mass. Now, Aditi, the empirical formula is already given. That is CH2. So what do you think? What will be the empirical formula mass? You have to just add the atomic masses. You have to just add the atomic masses. So the molar mass, I will explain you how you are going to do. Okay. So in this empirical formula, we have two atoms. One is the carbon and other two are the hydrogen. So what is the molecular mass of carbon? It will be 12, right? It's a 12. What is the molecular mass of hydrogen? It's a 1. But we have the 2 hydrogen atoms. So how much I am going to get? I am going to get it as a 14. 12 plus 2 is the 14. You are getting this point, Aditi?
Yes, sir.
Okay. So what are the 2 steps you are going to follow? Step 1, get the molecular mass. Step 2, get the multiplying factor. And then we will get our final answer. Okay. So let's see one by one. First, we will determine the molecular mass. Okay, let's put the values using m is equal to m r t whole divided by PV. So what is m? 0.176 gram. Units are very important. What is the value of R? 8.314 liter kilopascal. This will be given kilopascal, mole inverse, Kelvin inverse into temperature. Now, Aditi, degree Celsius is given. So convert this to Kelvin and tell me what is the value. How much it's going to come?
548.
Yes, absolutely correct. 500 or 400? Aditi, cross check.
400.
Yeah, it should be 400. 448 Kelvin. Very good. Good. Whole divided by. And as I mentioned, units are very important. Whole divided by 134 kilopascal. Volume. Volume should be in the liter. 35 multiplied by 10 raised to minus 3 liter. Right? So if you observe carefully, kilopascal, kilopascal gets cancelled, liter, liter gets cancelled, right? Even the Kelvin, Kelvin gets cancelled. So whatever the answer that is going to come will be gram per mole. So you are going to try how much it is going to come. Okay, just try. I will share the correct answer with you. Good, Aditi, you are getting this problem quickly. That's good thing. You are able to solve, or should I share the answer? Okay, no problem. See here. It should be 139.77 gram per mole. Right? It should be 139.77 gram per mole. Got it, Aditi?
Yes, sir.
Okay. Step 1 is done. Step 2, we are going to get the multiplying factor N. N is molar mass by the empirical formula mass, which we have calculated as a 14 gram per mole. So put the values 139.77 gram per mole whole divided by 14 gram per mole. This gets cancelled. So how much it's going to come? It's going to nearly come around 10. We are going to take the whole number. we will round it up to nearby whole number. Why? Because we want to multiply it to the empirical formula. Now the last step, step 3. Step 3 will be our answer. Molecular formula is equal to n multiplied by empirical formula. So that is nothing but 10 multiplied by CH2. Right, Aditi? I will write down this in the bracket so that you will not get confused. That is nothing but C10H20. This will be your final answer. C10H20. Got it, Aditi?
Yes, sir.
Okay, very good. And remember one thing. We have taken the nearest whole number. So you might be thinking, sir, 139 by 14, it's coming in the decimal point. So I have rounded off to nearby whole number. Good. Very good. So one more question we are going to solve. Yes, so this is what we have seen. Yes, question number 3. Aditi, so how you are going to proceed? What you will do? First, read the question carefully. Read the question.
Okay, sir. 123 gram of sucrose is dissolved in 568 gram of water. The solution has a density of 1.34 gram per milliliter. Determine the molarity and molarity of the solution.
Very good. So what is asked? Molarity and the molality is asked. What is given? The solute mass is given. Solute mass, we will consider it as a M solute. Now in this problem, the solvent mass is also given. Solvent is a water. And the density of solution is given. This is very important, Aditi. Always try to focus on what is given and what is asked. Then the next step will be how we are going to proceed. Solution. Now, Aditi, we know that if I say molarity, molarity is nothing but moles of solute divided by volume of solution. Solution volume, but it should be in the liter. Okay, that is the molarity. Now you might be asking, what is molality? Molality. It is nothing but moles of solute divided by mass of solvent. Here we are not taking the volume. We are taking the mass of solvent, which should be in the kg. Got it, Aditi? What is molarity and what is molality? Okay. Very simply, I have explained this. Now the next step is the using the given data to get the molarity and the molality. First thing, step 1. Get the moles of solute. Moles of solute. So how we are going to get the moles of solute? Mass of solute divided by the molar mass. Mass of solute divided by the molar mass of solute. This will be given, Aditi, don't worry. So what is the mass of the solute, Aditi? Here we can clearly see it's a 123 gram, right? It's a 123 gram. What is the molar mass? It's a sucrose. So sucrose molar mass is 342 because the formula is C12H22O11. This will be again given 342 gram per mole. So you are going to solve this, Aditi. Just quickly solve and tell me the answer. You are there, Aditi? It should be 0.3596 mole. Okay? 0.3596 mole. Understood this?
Yes, sir.
Okay, good. Now, Aditi, we have the moles. Moles are, we already have. Even the mass of solvent we have. But one thing we don't have. We don't have the volume of the solution. How to get the volume of the solution? We are going to get it from the density. So step 2. Volume of solution. Always proceed step by step, Aditi. Volume of solution from the density I mentioned. So how we will get it? Mass of the solution whole divided by the density of the solution. So let's check this. Now, Aditi, mass of the solution means solute plus solvent. So how much it is? 123 plus 568 gram, because both are given. What is the density? Density is 1.34 gram per ml. So if you solve this, how much it is going to come? Aditi, it should be 515.67 milliliter. And if you want in the liter, how much it will be? 0.515 liter. We will take up to 3 decimal. Okay. So this is your answer. As I mentioned, the units are very important. Here, gram gets cancelled. So the unit will be in the ml. Got it, Aditi?
Yes, sir.
Okay, very good. So remember, mole is 0.3596. The volume of the solution is 0.515 liter. Now the next step is very easy. So you are going to use these values. So let's check this. As I mentioned, molarity. So put the values. Solute moles. Solute moles divided by the volume of the solution. So how much answer you will get? 0.6974 mole per liter. Then the molality, again the solute moles, but this time you are going to take the mass of the solvent, which is in the kg. That is 0.568. Put the values and you will get the answer. Okay. So what are your final answers? The final answers are, this is a molarity, which is 0.6974 mole per liter. And this is molality, 0.633 mole. Here we need to make one correction. It should be kg. It should be kg. Okay, Aditi?
Okay, sir.
Okay, very good. Okay, that's it for today. Is there any doubt, Aditi, or you understood all the 3 numericals?
Yes, sir. I understand.
Okay, okay, very good. Okay, okay. Thank you for choosing eTutor World, Aditi. Bye bye.
Nice.